I'll get started, Jakub. Maybe we can start with a short round of introductions from ourselves. So please, Jakub, you mind?
Well, I started this whole thing, so Zeta Alpha,
I think it's fair for you.
a crazy idea, and we want to keep you informed and up to date on AI and data science, and we're doing it a little bit as our own hobby as well. So yeah, glad to be here, and thanks for making time for us in your Friday afternoon.
Yeah, great. Marzi, please.
Yeah, hi everyone. I'm Marzi from a very lovely day in Amsterdam. And I'm responsible for the NLP research that we do at Zeta Alpha. So if you have been the user of our platform, I've been working mostly on the neural search. And I'm really excited about the works that we are going to talk about today.
Thank you. And finally, I'm Sergi. I've been working at Zeta Alpha also for a couple of years, and yeah, I'm responsible for trying to figure out and make a bit of sense of all of the stuff that's happening in the ML world, which is no easy task, I would say, with the amount of stuff that's coming out daily. I'm also super excited about the works that we're going to discuss today. I feel like after last webinar's edition, there was a bit kind of after the summer break, I did feel like the pace slowed down a little bit, but this past month, like the amount of news and papers and new research that has come out has been quite large. So I think it's a lot of stuff to discuss. So that said, I think Jakub, you'd like to give a short intro about what we're doing and.
Well, here's some. So I do hope that our platform makes it a lot easier for you by now, Sergi. So
yeah, it does.
And for our audience. But here's some of the snippets we're going to talk about, but we'll come to all of them later. So I just want to mention a couple of kind of big items that came by in the past 4 weeks or so. I think the biggest splash in the land of AI has been made by Facebook, because now they're renamed the whole company Meta, and they're building the metaverse. And some people say it's just to escape the sort of negative publicity that they had with the hearings in the US Congress. Some say that they've been planning all of this all along with the Oculus acquisition years ago and virtual reality and that. Some have been joking that now the Facebook AI team, now that it's been rebranded to the Meta AI team, is only allowed to do meta learning from now. So no regular machine learning anymore. Well, we'll see about it. I think one of the sort of biggest things that happened there is there was announced just now a few days ago, is that also I think as part of this push to get away from bad publicity, they're shutting down the face recognition system on Facebook. So that's pretty big news, I think. What do you guys think?
It's pretty big indeed, yeah.
So now you no longer have to wear masks. Your pictures.
Yeah.
Yeah, I don't know. For me, I feel like it's going to be rebranded with something else now that maybe that has a bad connotation, but they are not going to abandon the whole line of research.
I think you think they're just not going to call it face recognition anymore, but they're going to call it something else. Yeah. Meta recognition of faces. Well, our semantic search will find it. And so two other big things that we're going to come back to a little bit more. There's a lot of conferences. I think half of the NLP world is flying out at this very moment to the Dominican Republic. We're very, very jealous. We also think it's a bit, not so much in line with the sign of the times in the week where the climate summit is going on in Glasgow, to then be jetting off to a tropical island to have an NLP conference. But I wish I would have been there. So a little bit of jealousy as well there.
Yeah.
But we're going to attend virtually, and ICCV, the big computer vision conference, has been going on 2 weeks ago. So we're also going to talk about that a little bit. So before we dive into all of that, a little commercial promo. So for those of you who are not familiar with what we are doing at Zeta Alpha, so obviously we do a lot of R&D ourselves in neural information retrieval and NLP. But our goal is to build this platform using AI to help AI and data science teams stay on top of things in our own field of knowledge. We're using it a lot ourselves, and we think it's a definitely more pleasant and smarter way to discover and organize knowledge in our field. And our sort of end goal is to become this really smart research assistant. So you can go to the Dominican Republic and your research is going on while you're lying on the beach. So I won't give you like a full fly through of our whole platform, but the core of it is that you do discovery assisted by Marzi's neural search magic. So you can kind of type anything and we will try to understand what you mean using neural search and all kinds of nifty tricks like find similar and visualization using signals from codes, from GitHub, but also from Twitter, from social media, like what's being talked about. And once you discover things, you can organize them into the system of tags. And these tags actually become your research assistant. They kind of start to filter what's coming out. And you will receive recommendations on a need-to-know basis, tailored to your personal interest. And you can do that by yourself, but also in teams. So that's very quick commercial promo of our platform. But I want to show you how it's actually making Sergi's life easier, because what we do at the end of each month to discover what's trending is simply this. So we have all these sources like arXiv and the conferences and EMNLP and all that. And what we basically, Sergi's work amounts to is selecting for the last month, and then not sorting by date or by relevance, but sorting by popularity. And here it goes. These are the papers we're going to be talking about. Well, it's a little bit more complicated, right?
I would like to claim that I do just a little bit more than that, but that's the gist of it.
Wow.
Are we trying? Yeah. Are we trying to replace Sergi with our platform?
No. The human touch.
Maybe that's a secret plan.
Makes it shine.
Yeah, the understanding part. That's the main one. That's missing.
Yeah.
And knowing what's interesting and there's a lot more to it. Anyway, so let's dive back into the slides. And I just want to say one more last thing about the platform. For those of you who are already using it, we're really excited that we're bringing a new feature. I think early next week we'll be releasing it. And that's about making it possible for you to import any sort of private documents, whether they're scientific papers or just, project notes, but also if you already have a whole reference collection in one of these sort of bit prehistoric reference managers like Zotero or Mendeley, you can just import them and bootstrap your recommendation engine in Zeta Alpha with that. So coming soon next week.
Yeah, we're testing that as we speak, I believe, by some colleagues here.
Yes,
all right.
Around you see the people typing the last.
Yeah. All right. Let's dive into the topics for this month. So for the ones who are not familiar, we do this every month. We try to collect like interesting news, code, and research that's happening, and try to make a useful summary for people in the in the industry of research to sort of get a bird's eye view on what's happening in ML world. And the first piece of sort of beat that I wanted to bring attention to is that we are right now at November 2021, so we can start to look at what are the trends in publishing in arXiv. And I think it's interesting to
Did you
sort of
mention
wonder.
that the blog? Mention the blog.
Oh, sorry. Yeah, this is condensed also into a blog form. You can go to our website, and I wrote this blog post that it's pretty much a written version of what we're gonna talk about today.
All right, so let's talk about publishing.
Yes, let's talk about publishing. So something that we had seen for several years now to come was that there had been a pretty consistent growth between 30 to 40% year on year on the number of publications related to data science, machine learning, artificial intelligence. And it does look like this is the first year where that trend is going to break quite substantially. Like it's going to be around 48,000 at the end of the year, which is only a 10% growth with respect to last year. And we were internally wondering, like, to what degree this corresponds to to a meaningful trend. Is it only like a late, kind of delayed pandemic, post-pandemic effect? Yeah, what do you guys think?
Yeah, we were first really doubting. We were checking all our crawlers and checking the numbers, but it really seems to be true, right? That this is
yeah.
Slowdown in number of publications. It's not actually slowdown. It's a slowdown of the acceleration, right?
Yeah, it's a second derivative thing, but
yeah,
but still nonetheless interesting.
Yeah, so I think because there was no decrease in the number of conferences or the acceptance ratio of conferences. So in that sense, the number of publications should remain the same more or less, or maybe go higher because the submissions go higher. But maybe this is showing a trend of people just putting their own in progress work or unpublished work on arXiv, and now they're doing that less. And why is that? That's the question that we don't really know.
Yeah, it could be really a pandemic effect that it's going to pick back up. But I also think it's kind of constrained by the number of people who are coming into the field. I think in the sort of between 2015 and 20, you saw a lot of new people coming into the field, and like the number of students was just exploding, and now it's a little bit more constant.
Mm-hmm. Yeah. Could be. I mean, it will be definitely interesting to see over the next few months and just to see how that develops. Yeah,
but
so
I thought it's like people writing, like papers with 200 pages, like the foundational or the OpenAI papers by now. And I think, Marzi, some of the papers you've read, they're like 100 pages. So obviously you're going to get less papers if you write more pages, right?
Yeah, maybe we should start counting number of pages published on arXiv, right? That would be
that's a very slippery slope, like quantifying the quality of research.
Okay, so the next, very briefly, I wanted to mention, because there's actually not that many details to it, was this actually the biggest transformer ever published with a huge asterisk, which is the biggest monolithic transformer from Microsoft, Megatron Turing NLG, with 530 billion parameters, which is around 3 times what GPT-3 had. There have been bigger mixer of expert models, which means that there are models that have a complete number of parameters that's higher, but at inference or one training step time, only a subset of those parameters are activated. So it's not like really fair to compare them side by side. Unfortunately, like I said, this is only a blog post. It is a bit of a sort of a showing muscle from Microsoft of how their infrastructure is really, really good and state of the art. But I don't know. We'll see if they publish something a bit more technical on the topic, and we can kind of dive into what they did with this.
Yeah, it's a bit of a showcase for this deep speed framework.
Indeed,
for distributed.
They have their framework for distributed training. Yeah, absolutely. Go check it out. The blog post. It has all the training details, like the hardware.
Megatron Turing. It's a collaboration between Nvidia and Microsoft. Actually, I think the Megatron was started by Nvidia, right?
I believe so. Yeah. And yeah, thirdly, this state of the AI report that has been going for a few years, I believe now, Jakob, maybe you can give us a bit of
Yeah, I'm not sure how many years they've been doing it, but it's by these two kind of investors, Nathan Benaich and Ian, I forget his last name. Anyway, they're publishing this really comprehensive study once a year. So if you want to know kind of where we are in all kinds of areas, from applications to talent to what's going on in industry and hardware and software and geopolitics, then well, we're not gonna talk about it a lot here, except that indeed, as we've already observed, the transformer architecture has kind of taken all of machine learning over, more or less. Well, not entirely. There's still XGBoost, but they don't mention that, I think. Well, anyway, if you like this,
I think it's super interesting because it really gives these super, varied angles from which probably most people don't kind of. I haven't seen this kind of document elsewhere.
You can just download it on state-of.ai.
Yeah.
And in another piece of headline-making news, very recently, I think it was 18th of October, we heard that DeepMind, a division of Google, which wants to be independent but is less independent every day, is announced that it's acquiring MuJoCo. And what is MuJoCo? It's a simulator for robotics and reinforcement learning type of things. In the clip, you see one example, which was actually a DeepMind paper about learning to play soccer by reinforcement learning. I think Ajax played a little bit better this week, but anyway, it was kind of big news because it was a software package that was distributed commercially by this guy at the University of Washington who wrote it. He had his little company and he was asking for a decent amount of money to use that software. So now it's a big deal because it's on GitHub and DeepMind open sourced it basically. So what else is there to say about it? Well, I think just want to point your attention to these two papers. One is a comparison of popular simulation environments if you were looking for an alternative to MuJoCo. This is definitely a paper to check out. This came out in March of this year, and it shows you kind of the pros and cons. And we mentioned in a previous blog, I think it was trending in August, this ISAC-GYM, which is a kind of competing framework from Nvidia. But it's also free and open source. So.
We have a quick question from the chat. I believe you mentioned it before, Jakub. Where was the guy who initiated
University of Washington.
University was?
Yeah.
Okay, Washington.
I can look up his name in a second and let you know. It was a company called the Roboti. He's a professor at the University of Washington.
Well, one good outcome of it is that it's open source now. So
yeah, definitely.
Yeah, absolutely. Yeah.
Won't complain too much.
and then finally, this paper in the domain of ethics, right? I believe this is an interesting paper, quite ambitious because in what it does. Can you give us a elevator pitch, Jakub, for what this?
Yeah, well, so it's a very nice paper to read because what they did is kind of take one of these huge language models, kind of T5 or even GPT-3 style model, and they fine-tuned it on a corpus that they collected of common sense ethics judgment. So it's like a little statement, and then there's a kind of crowdsourced ethics judgment along the lines of like it's okay or it's wrong or it's completely morally unacceptable or whatever, right? So just a small classification task. And it's this group also from the University of Washington, from Li-Wei Jiang and co-authors from Ye-Jin Choi's group there. And Ye-Jin Choi always uses this example of the cheeseburger killing or something like that. And I think she actually tried this in this paper. And it's, yeah, you can train a very large language model to know that stabbing somebody with a cheeseburger is more morally acceptable than stabbing somebody over a cheeseburger. So what's really nice is you can try this out. So on delphi.allenai.org, you can type your own moral dilemma, and it will pass judgment on it. And it's about 92% correct on this data set they used to on a held out version of the data set. So is it really about ethics?
Excellent.
Marzi, what do you think?
Yeah, I mean, it's a step towards that direction, I would say.
It's maybe a little bit of a clever hands type of syndrome, but I decided to give it a kind of moral dilemma related to our very own business model and also to the Google's acquisition of MuJoCo. So I gave as an input, as a company, I'm offering a paid professional product, software product, collecting lots of data about my users, but I am restricting access to that personal data to only those users. So it's pretty much what we're doing. It's ethical.
Yay.
We're on the good side of it. Or the model made a mistake. That's also possible. And then as a counterexample, as a company, I'm offering a free and very engaging product. Let's call it web search, collecting lots of data about my users. And I'm then selling access to those users to the highest bidder in auction style based on their personal data. We think it's normal, right? You do it every day. Yeah. Well, Delphi thinks it's not okay. Sorry.
Nice.
So Sergi, what about the OpenAI?
Yeah, with that,
okay?
we'd like to move. Sorry?
Is OpenAI okay ethically?
I think it depends on who you ask. They do some interesting research, although some people question their ultimate, research agendas. But I think these are really interesting papers. So this is recursively summarizing books by OpenAI. It's a little bit more than a month old. We didn't get to cover it last month, but I think it's interesting to mention it. Basically, they wonder, like, there's some tasks like summarizing books where collecting annotations is really expensive, right? If you ask someone to summarize a book, it's gonna take in the neighborhood of 10 to 20 hours depending on the book, and that's only one sample. So so that would be prohibitively expensive to annotate completely. So what they propose is to say, okay, what if we just frame this task as a recursive task of summarizing things every step at a time, like 5 to 10x, and then summarize a book by recursively applying this model. And they do pretty much that. They do like it just like again, most of OpenAI papers are kind of a showcase of really great engineering at scale applied really well, and it's what they do here. Some interesting things to note here. A big caveat: this model is still pretty bad. Like the best way that they summarize it, I think, in the paper is that with their best model, only 5% of the summarized books are comparable quality to human. So there's still a huge way to go. Plus, they make a lot of factual errors. There's no a lot of these things. However, there's some interesting points, such for instance that the fact that the model size does correlate with the human judgments of the summary quality. So this sort of begs the question of, so is scaling up what all we're gonna need, or is there gonna be something more there? And also, lastly, Gary Marcus also used the opportunity to sort of claim once more that this was sort of neurosymbolic, because this algorithm of basically getting a book and chunking it into pieces iteratively, it's pretty much defined inductive bias. It's not learned in any way. They just sort of design it that way. So that's, you could make the argument that that's a symbolic innate bias that you
I think Gary Marcus has
the
innate bias to say things like that.
That's a really fair comment, I would say. If you train the language model on his Twitter feed, I'm pretty sure that would come up pretty often.
A kind of meta Gary Marcus.
All right, so let's jump. Sorry.
Maybe Sergi, before going, I had actually one question about that paper. So did they do anything about evaluation in particular, or do they just have like human generated summaries and then just compare?
So they actually, during training, they use a combination of two techniques, which is what they call behavioral cloning and human preferences. So what that means is there's a bunch of humans like summarizing text, and then a model trying to generate those summaries. And then at the same time, these human preferences where it's like a pairwise thing where humans sort of pick which one of two summaries is best. And then the model is trained on a policy that optimizes the expected reward of choosing the best summary, basically.
So the 5% is included with the human in the loop evaluation.
Yeah, exactly. So the evaluation is completely based on these Likert scores are like human afterwards that evaluate on a test set of books.
Nice.
And now if we jump to the next one, I also quite like this one. Exploring the limits of large-scale pre-training. This was a paper done, I believe, in Amsterdam by Samira and colleagues that I think Marzi knows very well. And it's one, again, paper that basically explores this space of scaling laws, of like seeing, okay, what sort of big aggregation laws happen when you scale things up. And I think it's super interesting to sort of find things that we humans with our limited brains can understand about what happened, or what's up with these big neural networks. So Marzi, can you give us a summary of what this paper does and what is interesting about it?
Yeah, sure. So like you said, it's like it's a very interesting work done by 4 very smart people, and I know 3 of them, so I'm not biased.
Slightly biased.
It's an informed comment, but I like the general idea. So places
they all
like
play at Ajax, right? They play soccer at Ajax, I think, all of them.
Companies like Google, which this work has been done, they have this great repertoire of experiments, pre-trained models, the data sets that they have. So what these people do in this work is that they don't, they do also train some models, but they mainly use this huge collection of available pre-trained models and data and weights and everything. So they basically pick, I think, around 5,000 experiments done over time by Google. So, and they call it a meta-learning study. So no pun intended there. So the general idea is that looking at the task of supervised learning in image, basically dealing with image data. So the task can be like image recognition or any other image related task, and how the transfer learning basically scale. And they look in particular into the pre-trained tasks and data, which they call the upstream set, and also the downstream set. So the task that we transfer information to, we transfer the models that we learn to evaluate on. And they look at 2 scenarios mostly. So one is fine-tuning on downstream tasks, and the other is doing few-shot learning on these tasks. And they show some interesting behavior. So firstly, there's this really large graph here showcasing the 5,000 experiments, and how and each of these plots are different image data sets, and they show how the relation between the accuracy of upstream task and the downstream task, it saturates over time. There is also this interesting finding that they try to also run a controlled experiment with the same data sets and tasks, but they only change hyperparameters in the model. So in the other graph on the right side, and they see that the saturation behavior is still happening there. So that's
So you would say that this, because I guess one of the big questions when you do this kind of large scale, a lot of training data, like you can sort of wonder to what degree this is robust to hyperparameters, because it might be that you're randomly choosing really good hyperparameters for one set of models, but not for the others. So you would say that their findings are kind of justifiably robust to these kind of things?
Yeah, I think the control experiment showed that empirically, because the other, so the 5,000 experiments, at the end of the day, they are optimizing for a particular downstream task, so they might not be using the best hyperparameter. But in their control setting, they are focusing on different hyperparameters and changing that over time, basically. And I think another interesting finding here is that you see that the numbers don't quite overlap, like their control experiment and the ones that exist before. So what they infer is that, well, model size, number of parameters, data size, how many epochs you run the experiments, all of these matter, but it looks like there are other things that matter as well. So the architectural differences of these models, for instance. And yeah, I think I don't want to talk too much about this paper, but as a conclusion, what they conclude, and I also agree with, is that this narrative that scaling can lead to great models that then can be used in any task, it might not be entirely correct. So there might not be one model that fits all, and you have to really look at your downstream tasks, and you have to add diversity to your downstream task in order to train and pick a good model.
Mm-hmm. So diversity is more important than scale at some point.
So this other scaling laws, the original scaling laws paper, people printed like T-shirts with the graphs from the paper, because general artificial intelligence is at the end of the scaling curve, basically, right? Real believers wear the T-shirts. Are people gonna wear T-shirts with these graphs as well?
I think it's the idea is to add one other dimension to that. So not that scaling doesn't really matter, but this is also something else that is important. But yeah, why not? We are all
so
progressing forward.
To close off, I wanted to point out that I would really like to see a kind of work like this on language tasks, probably because this, like you said, is focused on vision. And secondly, I do think that's very interesting, especially because in my opinion, we're now in a context where nobody really trains from scratch anymore. So people are always gonna pick up a pre-trained model from scratch, right? So it's really it's really important for people to know how well a pre-trained model will transfer to your particular task and understand that better, because it's really the dominant paradigm in machine learning.
Yeah, that's a very good point. And we also have been seeing that in our own research at Zeta Alpha. So it's definitely a good point.
Yeah. All right. So next up, yeah, I think that this paper can be summarized pretty quickly. So a few more examples, maybe worth billion of parameters, is asking the question, okay, so imagine you can only do one of two things, which is scaling up or adding or labeling more data. And applying this to a set of NLP tasks, classification, extractive question answering, multiple choice, and open question answering, and seeing how this affects the different scenarios. And the interesting thing you can see in this figure is that you would expect that adding parameters and adding examples would universally improve performance. So you would expect in these figures to see sort of a gradient along the diagonal. So as you increase both things, the performance increases, but you can see that that's only true for a subset of the tasks. Whereas for classification, extractive question answering, and multiple choice. However, for open question answering, it does seem that scaling parameters is a way more optimal way of increasing performance, whereas adding examples, at least at that scale that they're trying, because they don't explore that much scale, doesn't add that much performance. And I think this is really interesting in the context of, we're probably, a lot of people want to solve a task and use machine learning for it. So they're constantly making decisions about where they allocate some limited resources. So this is indeed quite interesting in that context. That said, I do want to point out that this is a pretty limited study, so there's a lot of caveats, and we should, before drawing conclusions, wait to see these, replicated by other people or applied to other tasks. But I definitely think that this sort of question is a really interesting and meaningful one to explore. So really interesting. I think we should move on quickly to the next one, because we still have a lot of
That's a very nice one, huh?
yeah. So someone asked for Hugging Face stuff in the chat, so this is somewhat related. This is the first paper coming from the BigScience effort that I think was spearheaded by Hugging Face and a couple of other institutions, which we had Thomas Wolf in our Transformers at Work event talk about this. They basically identified that this trend of big language models was an interesting research direction that was gonna keep coming, but that only big companies had the kind of resources to pull that off. So they wondered, okay, what do other communities like the physicists do? They pretty much get together, ask for funding together, and they do experiments together. So they try to sort of replicate that. And this is the first paper that came out of that. So this is an effort from a lot of people. You're going to see that the author list from this paper is really long. But I think it's a really interesting direction that we're probably going to see more and more as large scale research becomes more and more dominant. Probably academic groups are going to have to come together to unite forces. That said, Marzi, can you explain to us what this paper does?
Yeah, sure. So very briefly, this paper is another work in the recent trend in NLP of working with prompts. And prompts, as many works have shown, are really good way of communicating with these large language models and benefit from them. So what they propose is, they call it this multitask prompted training. And it includes two steps. So one is gathering prompts, and then the second is training. So what they do for prompts creation is a community effort of, so they pick like multiple NLP tasks, and for each task they want to create prompts that are based on the idea of the task, but also what they call a creative way of prompting to get answers from the task. So you see one example of a prompt here, but they also have in the paper, they also published like all of the prompts that they gathered and the training data that they created, so you can replicate their numbers. So yeah, the main idea is to create this huge set of prompts, which are in the format of input sentence or multiple sentences and the target sentence. And then they train an encoder-decoder transformer model given these sentences. And all of them, for every task, the format is the same. So they basically mix the prompts and the samples from tasks, but proportional to the sizes of the data set for each task. And then they train a model. So what they actually do for training is important to note is that they pick a pre-trained model that was trained on masked language modeling and then trained on the standard language modeling of prediction of next word. And then they fine-tune that on this multitask prompt data that they gather. So they show very interesting results. Here you see they compare with, so the blue lines are the different versions of the GPT-3, and the two green bars are, well, one of them is the T0 model, which is multitask training proposed in this work, and the T5 plus LM model is a model that was trained on language modeling, but with the same models and prompts as this data set. And you see that it's performing relatively well in all of the tasks, and in a lot of them, it's also working better than GPT-3.
Yeah, so I mean, like you said, this T0 model includes sort of labeled data during training. So I guess a question to wonder about is like, to what degree most of the comparisons they draw is with GPT-3, right? And GPT-3 was only trained with a completely raw, well, not raw, but like not annotated data set. So like, to what degree do you think that these comparisons are meaningful or useful or like fair? Or
yeah, that's a good question. So as you know, the architecture of the two models are different. So GPT-3 doesn't really have an encoder and is mostly trained on prediction of the next word. But here we have an encoder and the decoder actually hasn't seen the input text at all. So in GPT-3, you have seen the text, but in T0, you haven't. They do try in their experiments to exclude the data that GPT-3 was trained and evaluated on to make it a bit more fair comparison. But I think the point of comparing here is not necessarily that this model is exactly or very similar, but it's doing better, but rather that this is an open source attempt on data and model, and it is working as well, if not better, as GPT-3 with the label data that is also available. So I think if you look at it like this, then it's not about like who is winning really, but in case of like in practical use, who can benefit from using each of these models.
Yeah, that is a really big deal that they open source it. I think they should have also compared it to this Eleuther. That's the other big GPT-3 like model that was open source, right?
Yeah, the GPT-J, you mean, right?
Yeah, exactly, GPT-J.
Yeah, exactly. Absolutely.
And is this model a WAPI or what?
Sorry?
What are these examples there? Is this model, as they say in Dutch, a WAPI?
Yeah, so they do actually provide an analysis in appendix on where it still fails. So yeah, don't take this model as something that is like great and solves everything. And here are some examples as what like the question as the input and the prediction of the model. So there is still this gender biases, there's misinformation there, and this actually showcases I don't want to say like problem, but like the situation with the data that all of these models use. So as long as they're also straightforward about these problems, I think that's a good way of promoting an open source model.
Maybe we can be solved with prompt engineering, like answer this question, but not like a WAPI.
Yeah, so I just wanted to finish this by saying that I believe that they're gonna be publishing more papers from this effort, right? This is gonna be like an ongoing thing. So I'm really looking forward to what they publish next. I think that they're gonna focus on the multimodal, sorry, not multimodal, multilingual sort of things, which I think is really interesting and excited as a speaker of a small language. Yeah, so next paper, Speech-5, also really quickly because we still have a lot in the pipeline. This paper explores language modeling with audio data. So I think this was really interesting because I feel like when we talk about NLP, we often sort of imply that we're talking about text, whereas language is a way older thing than text in the spoken form. So I think that this is really interesting and refreshing, and I'm really looking forward to seeing more, works that explore the combining modalities of data like text and audio, because of course, spoken language has a lot of nuance. And now that the models are, we're starting to see models that are big enough to sort of deal with that kind of data. I'm really looking forward to seeing more models like this. Yeah, basically, they train this model jointly with audio and text, and they achieve really good performance, a lot of speech benchmarks. Yeah, I don't think we have time to go a bit more in depth with that. Finally, I think in the research papers, we wanted to highlight this neural rendering paper that I think is kind of a very eye-candy, super cool application of neural networks.
Jacob, the most discussed paper on Twitter, the most discussed AI paper on Twitter for the last month or so. And
yeah, I mean, if you haven't seen the video, they have a really nice video on YouTube, the authors, where they explain like an overview of this, and they have some demos. We have here like a short GIF about it, but it's really impressive what they achieve.
Yeah, well, so if we're gonna build the metaverse, right, we're gonna need really good rendering. And what they do here is basically, if you have like a 3D model from a point cloud or something, and then you just have a bunch of pictures that you can grab the texture from and the sort of the overall look of the objects, you can render super efficiently very nice 3D fly through. So that's gonna, like, Mark Zuckerberg is gonna need this stuff, and apparently it's a big breakthrough, but it's not our field of expertise. But the demos look really impressive, and the code is open source.
Yeah. You can go try it and
it's one of the fastest rising repos on GitHub, I think, at this moment.
Yeah, absolutely.
So
I think next up, we're gonna have a couple of comments on EMNLP, right, Jakub?
Yeah, so EMNLP is starting this weekend. As I said, many of our NLP colleagues are flying to the Dominican Republic. We pity them, and we are very jealous and all that. It's a lot of papers with the findings and all the workshops. So at almost 1,700 papers in EMNLP. And how do you kind of dive into it? Well, this week the best papers were already announced. So the winner of the best long paper is a data set paper, actually, visually grounded reasoning across languages and cultures, which does a little bit of sort of multicultural, multimodal crowdsourcing of images and basically captions or descriptions of those images. And I think it's a very nice data set. There's a couple other, like on humor, computational humor, one best short paper. There's a bunch of outstanding papers that you can check out. And well, we didn't mention Hugging Face enough yet, but of course they won the best demo paper with the
second year in a row, I believe.
Yeah,
I think they won also the for their Transformers library.
Exactly. So the data sets library, I think that's a big deal also for everybody in the field and practitioners. It just makes it really easy to have access to all these data sets. So what's in the rest of these almost 1,700 papers? Well, we just want to invite you to use our platform with the this semantic map visualization that we've built together with University of Leiden, the VOS viewer. So we basically are able to take all the EMNLP papers. We actually imported them yesterday. So you might have gotten a lot of recommendations today if you're using the platform and interested in NLP. But basically, yeah, we're not going to have a lot of time to fly through it really, but with this link, you can yeah,
and we're going to be sharing some interesting findings that we find on Twitter.
Yeah, we're going to be live tweeting next week, and we're going to be at the conference, so hit us up there. But basically, I just want to show a few nice little clusters here. There's some knowledge graph cluster here. There's a dialogue cluster here. So it's like kind of a good way to find your way around. And the cluster which we are interested in the most is down here because it's about dense retrieval. So there's about like 30 new papers on dense retrieval and question answering with denser representations that I'm really excited to try out. And probably, Marcy, this cluster here is about machine translation. So you might revisit some of your old friends and colleagues there.
Yeah, so it's really, I mean, in-person conferences would have been good, but I'm still excited for an online attendance of the EMNLP.
Sunday it's starting. All right. Well, I'm gonna be sleeping on Sunday, but well, maybe. All right, another conference that I wanted to mention, we also imported it last week. It took place about 2 weeks ago, ICCV, big computer vision conference, 1,200 papers. Best paper award went to the Swin transformer. Hey, we've heard that before. I think we covered it in this webinar.
We did cover it, yeah, indeed.
No wonder, because actually the paper, I think it's from Microsoft Research Asia. It came out in March on arXiv. So if you really want to kind of stay on top of things, maybe it's good to watch arXiv a little bit more through Zeta Alpha and not wait for ICCV. Another best paper was the best student paper at ICCV, was this pixel perfect structure from motion, which I think again is kind of a foul play by Mark Zuckerberg to get some better looks for the metaverse. But it's a cool paper by some German guys. And again, we have the data, so we can do this visualization, and you can spend your weekend browsing it on our platform. And I just want to dive in a little bit and look at this cluster here. So there's obviously in computer vision a whole lot of work on perception for automotive, right? So self-driving cars, there's the dilemma on whether we will use LiDAR or cameras only, or both. Well, certainly there's ICCV a lot of work on object recognition and trajectory and path prediction and all that around cars. And I just want to use that the last few minutes of our webinar to do like a mini special on AI in automotive. We're going to be doing a little bit more of that soon, but just a quick glance at some recent work in AI for automotive applications. So this really nice paper, event-guided depth sensing, proposes a kind of biologically inspired model where depth sensors like LiDAR are kind of focusing their energy and their strength on particular segments of the image where something interesting is going on. So it's a little bit like a fly's eye or a human eye, where like the fovea is directed at the most interesting part. So what they did not know is that there was actually in 2019 already a paper. I checked the references, it's not cited, so related work. If you think that in a automotive is only about vision, no, there's a lot of other machine learning applications in automotive. For example, to predict battery life and like improve battery management. So there's this whole cycle of or set of works recently about this kind of predictive maintenance type of things, and to charge or to sell is an interesting paper about that. One more paper I wanted to mention is Safety Net. So this is from a team that used to be at Lyft. Lyft sold the whole division for self-driving cars to Toyota. It's now called Woven Planet. And these guys are basically writing their work up in this paper Safety Net, which came out a little bit over a month ago. And I just tossed it into our Find Similar, and you see that it's kind of a trend. So there's a lot of work in sort of this automotive perception going end to end. So basically going training these whole set of modules from the raw perception all the way to the planning and the safety and collision avoidance type of thing. So check out some of these works. Well, obviously, safety in self-driving cars depends a lot on also not being fooled by adversarial attacks. So this is also an interesting recent paper, which aims to address like when people are trying to fool one of the sensors, the LiDAR or the camera, and that kind of the system can detect that and shut down that sensor to avoid an accident. So that's a few papers in AI and automotive, but I think as a closing word, I think there's still a lot of very challenging situations. And this paper shows that when you want to roll out self-driving cars beyond the suburbs of America, there's a lot of work to do. These guys, it's an Indian team, published a large data set, Meteor, which shows complicated traffic situations in India. And if you want to have a good feeling for the plausibility of self-driving cars soon, check out this data set. It's really
there's a lot of specific examples, like you can see in these images that are
there. Some of them are pretty scary. Cutting across the road in the wrong direction through the red light. All right, so wrapping up, really wanted to share this gem with you. So if you're just getting started, you're not already an expert in self-driving cars, check out this blog post on Towards Data Science. In less than 500 lines of code, you can build your own self-parking car, maybe something for the weekend.
And I think that's brings us to the end of this webinar. I think it's pretty close to the hour, so that's great. I don't know, is there anything that you would like to add before we close this off, Jakub, Marzi?
We should do more questions. There's a lot of questions in the chat.
Yeah. Sorry, it's gonna be
we'll do better next
hard
time.
to,
Sorry, we'll come back to you with some answers offline.
We'll try to do better. So as a reminder, so we have all of these blog also published on our website. We are trying to constantly surface interesting stuff on Twitter. You can try our product and follow us on social media. And by the way, next month we're gonna do a special edition of this webinar and blog, especially focused around NeurIPS that is happening at the beginning of December.
Friday before NeurIPS starts. So
so that's gonna it's the biggest conference in AI, and every year is really amazing the content that they publish there. So really
last year there were like 20,000 people at there, and it's virtual again, so it should be the same.
Yeah.
And next week EMNLP, so we'll be live tweeting. And for those of you on the company and enterprise side, really interesting conference is also Nvidia GTC, which is going on at the same time as EMNLP next week. And for the Dutch and Belgian folks, there's also BNIC, but it's in Luxembourg. I'm not going.
So Yusuf asks why do you think NeurIPS is virtual whereas EMNLP is a hybrid version? Do you guys know why that decision? I'm guessing that a big part of it is that online conferences scale better, and NeurIPS is like a size that is probably
Yeah, so his question about hybrid, EMNLP is going to be hybrid, so you can still attend online. But I think it's like any other COVID regulations in like different countries, each have their own way of rolling out and going back to normal. So some conferences, they decide maybe it's time now, and some they wait.
So I think there was also this sentiment at EMNLP last year that like everybody really wanted to go to the beach in the Dominican Republic, and they kind of felt cheated out of it, and then now they're making up for it. Whereas in NeurIPS, there's always a lot of these more like ethics-oriented folks that are saying, no, it's not a good thing to fly all over the world. So I don't know.
We'll see in the upcoming months how this whole transition sort of
I think iClear is going to be in person, right? In 2022 next year.
I honestly don't know if about that, but we'll have to see.
I just reviewed a very, very interesting paper for iClear. So I think it might be appearing in next year's.
Great. Really looking forward to seeing that. All right, so I think it's time to sign off and wish everyone a nice weekend, and thank you for attending and joining us today.
It was fun. Have a good weekend.
See you in December. Bye-bye.
Bye-bye. See you.